In July of 1946, two nuclear explosion tests were conducted at Bikini Atoll in the Marshall Islands. The purpose of these tests was to investigate the effects of nuclear weapons on warships and the crew. There were over 90 vessels involved in the operation, mostly made up of decommissioned US Navy ships. And even though none of these ships were crewed, many animals, including guinea pigs, mice, pigs, and goats, had been placed in stations that would normally be occupied by people. But how this can protect warships against nuclear weapons is not what you think. The yield of a nuclear weapon measures the amount of explosive energy it can produce, and is calculated in terms of the quantity of TNT that would generate the same amount of energy when it explodes. For example, exploding a 1 kiloton nuclear weapon produces the same amount of energy as exploding 1,000 tons of TNT. In a nuclear explosion, there are three things that could impact a warship: the blast, the heat, and the radioactive contamination. About 50% of the energy released in a nuclear explosion is in the form of a blast. Its effects are usually measured by the amount of overpressure, the pressure in excess of the normal atmospheric value. The blast travels slightly faster than the speed of sound at sea level, and as you can imagine, it can be devastating, especially the closer you are to ground zero, the center of the explosion. Depending on the proximity of the blast to a warship, the effects can range anywhere from damaged eardrums and people blown off the deck to broken radars and equipment, and ultimately, destruction and sinking of the ship. There is not much that could be done to protect against the blast, but if the ship is far enough, the blast won't cause any serious damage. The thermal energy makes up 35% of a nuclear explosion. The heat from a nuclear explosion can be felt for tens of miles and can be damaging to those directly exposed to it. Anything combustible in close range will burst into flames. It's like being very close to the sun. But since this is thermal energy, as long as there is no direct hit, the effects can be minimized. Weather conditions like clouds or smoke in the air can considerably reduce the damage versus clear air conditions. Nuclear radiation makes up the remaining 15% of the energy released, and this is our focus for today. If the explosion is close to the water or land, a great volume of water or soil will be shot into the air, some of which will fall close to ground zero, while the rest is carried farther away by the wind and is later deposited as what's known as nuclear fallout. These radioactive materials can be damaging to the crew. Depending on the amount of exposure, it can have short-term or long-term health effects, and in extreme cases, can lead to death. The effects of nuclear radiation was obvious in Operation Crossroads. In fact, after the second explosion, the ships were so contaminated that a third scheduled nuclear test was canceled. Realizing the devastating effects of nuclear contamination, the US Navy started looking for a way to protect their ships against nuclear radiation and fallout. And after a series of tests, they came up with an idea. Some initial tests showed that hosing down the contaminated ship with water could remove the majority of the radioactive contamination. But this wasn't good enough, because the crew would have exposure to the contaminated surfaces prior to the ship being washed down. The ideal solution was to prevent the radioactive contamination from being deposited on the ship in the first place. The US Naval Radiological Defense Laboratory conducted a series of experiments where a radioactive mist was sprayed onto painted steel plates. Radio autographs of the dried steel plates showed a droplet distribution resembling that of radioactive fallout. The experiment was then repeated, but this time with saltwater jets flushing the steel plates during and after the contaminating spray. The results showed that the water had prevented or had removed 99% of the contamination from depositing. Promising, but this was done on a steel plate in a laboratory environment, as opposed to an actual ship. So in a series of follow-up tests, tens of nozzles were installed in strategic locations on the ships, and then hooked up to fire hoses that pumped seawater. These experiments highlighted some shortcomings. For example, the large volume of sprayed water would get stuck in poorly drained parts of the deck and superstructure, so an improved drainage system was needed. At the same time, it was determined that a zigzag maneuvering could help, as the resulting list would spill the majority of the trapped water. These experiments were done on cruisers, destroyers, and aircraft carriers, and even though these results confirmed what had been recorded under laboratory conditions, one more test was needed: the demonstration of the effectiveness of the countermeasure washdown system in a full-scale nuclear explosion. Operation Castle was a United States series of high-yield nuclear tests at Bikini Atoll, which began in March of 1954, almost 8 years after the nuclear explosions of Operation Crossroads. Operation Castle was intended to test lithium deuteride as a thermonuclear fusion fuel, which is solid at room temperature. If it worked, it would be far more practical than the cryogenic liquid deuterium fuel that had been used in previous tests. This provided a great opportunity to test out the new countermeasure washdown system as a side project. 2 ships were prepared. Yak-39 had a countermeasure washdown system installed, whereas Yak-40 had no washdown systems and was used as a point of reference. Both ships were fitted with drone controls, as neither one was to be crewed, and they were to sail side by side into contaminated areas after the explosions. Both ships were heavily equipped with instruments to measure things like gamma radiation levels. An F4U was also placed on the deck of each vessel to determine the degree of contamination and the consequent cleaning efforts required for aircraft on deck. The 2 Yags were involved in 4 nuclear explosions as part of Operation Castle. So what were the results? The unprotected aircraft that was on Yak-40 required thorough cleaning, whereas the aircraft on Yak-39, from a nuclear contamination point of view, was immediately flyable. Radiation data collected on the 2 Yags estimated that the washdown on the ship and the exposed aircraft averaged 95% effective. The contamination levels on the unprotected ship were so high that parts of the wooden deck had to be removed prior to bringing the ship back to the mainland. It was concluded that in heavy radioactive fallout areas, the washdown system can limit gamma radiation to tolerable levels below the deck, as well as minimize the effects so that after leaving the heavy fallout areas, immediate topside action would be possible on all weather surfaces of the ship. As a result of the tests performed as part of Operation Castle, all new construction and ship conversion design incorporated fully installed washdown systems which can operate indefinitely, using seawater from the ship's continuously replenished supply. The constant streams of water functioned as both a barrier and decontaminant. The water formed a fluid film over the ship's surfaces to dissolve the depositing seawater fallout and prevented most of the dissolved radionuclides from coming in contact with the ship's weather surfaces. Or if the seawater fallout did contact the surfaces, the water was intended to dissolve the residue and carried over the side into the ocean. We should add that the washdown system is also considered a defense system against chemical, biological, and radiological attacks.